Okay, now we're going to do some practice. Okay, so what I need you to do, if you don't already have a piece of paper out, I want you to get a piece of notebook paper out, and I want you to label it Naming Alkane Practice. Naming alkane practice. We're going to do a bunch of naming here, but we're also going to do some drawing at the end, but we can still just name it Naming Alkane Practice. So pause the movie and get a piece of paper, label it, and then we can resume. Okay, so our first molecule, I'm just going to show you a picture. Okay, here's our first molecule. I want you to try to use the rules that we just taught you to name this branched alkane. So go ahead and pause the video, look at this picture, work through it, and then hit resume or play to see me work through it and check your answer. So now that you've tried this one on your own, and please go back and try it on your own if you're not doing that, because this is how you practice, okay? If we look at this, the first step, remember, is find that longest chain, okay? So if we count here, 1, 2, 3, 4, 5, that's 5. 1, 2, 3, 4, 5, that's also 5. 1, 2, 3, 4, 5, all of them are 5. So it doesn't matter what you decide to make your parent chain, it's definitely going to have 5 carbons. I would usually just say, well, they're all 5, that's going to be my parent, this becomes my branch. Okay, then we're going to go ahead and number the parent chain. If we were to number this from left to right, the branch would be attached to carbon 3. If we were numbering it from right to left, it would still be attached to carbon 3. So this one is pretty simple. There's not a lot of choices here. The branch is attached to carbon 3. So when we name this, first off, that branch location is 3. All right, branch name. Well, how many carbons are in this branch? Okay, there's 2. And the prefix for 2 carbons is F. So ETH. But what's the ending for a branch? YL. So 3-ethyl. And then the 5 carbon parent chain is the last part of our name. 5 carbons is pent. All single bonds is ANE. We get pentane. 3-ethyl pentane. All right, here's number 2. So we got a skeleton structure. Remember, every point is a carbon. Go ahead and pause the video, try this one, and then hit play. First step when looking at this molecule, again, find that longest chain of carbons. Okay, 1, 2, 3, 4, 5, 6, 7, 8 if you count straight across. 1, 2, 3, 4, 5, 6, 7, 8 if you come down. 1, 2, 3, 4, 5, 6, 7 if you come this way. So this is not my parent chain, but this way coming around or this way all the way across, either way we have 8 carbons. So pick one. Again, I'm going to just pick this straight across. That's my 8 carbons. And then I have these 3 sticking off. That is my branch. All right, so we know that our parent chain has 8 carbons. Okay, that's the last part of our name, so let's just number the parent chain. If we number it from left to right, 1, 2, 3, 4, 5 is where my branch is attached. If we number from right to left, 1, 2, 3, 4 is where my branch is attached. So that's the correct direction to number. So we're going to end up with 4 for the branch location. There are 1, 2, 3 carbons in the branch, and the prefix for 3 carbons is prop. And the ending, again, because it's a branch, is YL. So 4 propyl. And then coming back here for the parent chain, 8 carbons long, is OCT, oct. And then we're still working with all single bonds, so all of our names are going to end with that nice ANE. So, final answer, 4 propyl octane. Okay, here's the next one. Condensed structure, hit pause, name it, and then hit play to see if you were right. Here, this one, I'm just going to go through it pretty quickly, okay? If we work, this is definitely the longest chain, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9 in that chain. Numbering it, 1, 2, 3, 4, 5 gives us our lower numbers. So 4 and 5, we're going to number it this way to give the branch locations the lowest possible numbers. So 9 carbons, carbons 4 and 5 both have a branch. This one only has 1 carbon in it, that's methyl. This one has 2 carbons. That's ethyl. When we name, you need to name them in order of alphabet according to that carbon prefix. Okay, so ethyl becomes before methyl in the alphabet, even though it's attached to a further carbon in the chain. So this one is 5-ethyl for this, then 4-methyl, and then my parent chain has 9 carbons. That is nonane. 5-ethyl, 4-methyl, nonane. Okay, 5-ethyl, 4-methyl, nonane. Remember, dashes between numbers and letters, spaces, okay? We only put commas if it's a number and a number next to it. Okay, question 4. Hit pause, name it, and then come back. So on this question, we've got 2 branches, okay? So first thing, parent chain, 1, 2, 3, 4, 1, 2, 3, 4. It doesn't matter what direction you work with, you've got 4 carbons. So parent chain for me is going to be this one. I've got 2 branches coming off the parent chain. It doesn't matter which order I number, 1, 2, 3, 4. That would give me carbons 2 and 3. The opposite, 1, 2, 3, 4, same thing. So carbons 2 and 3 both have a branch. They both have a single carbon, so they're both methyls. Now remember, with duplicate branches, you don't name them individually. You combine them and give them an additional prefix. So, location of the branches, 2, 3, because they're the same. I'm combining them into this part of the name. There are 2 of them, that's di for 2 of the same branch, but the branches only have 1 carbon, so meth means 1 carbon, so methyl, dimethyl. And then they're attached to a 4-carbon molecule, so BUT is my prefix for 4, and ANE for the single bonds. 2,3-dimethylbutane. All right, challenge 1. Number 5. Pause, draw, and then come back. Okay, here, the longest chain, again, there's a couple of options to give you the same length, but I'm just going to choose that straight across option. So 1, 2, 3, 4, 5, 6 is my parent chain. Now, attached to that parent chain, we have 3 branches. They're all a single carbon because there's only 1 point coming off of each of those. Okay, so single carbon branches are all methyls. Since they are the same, we're going to combine them in the name. Numbering my parent chain, 1, 2, 3, 4, 5, 3, 4, 5 versus 1, 2, 3, 4, 2, 3, 4 is lower. So that's the correct direction to number. So my locations of my branches are carbons 2, 3, and 4. So 2, 3, 4. List them with some commas. Put a little dash in there because we're going to get to some letters now. Because there's 3 of them, my prefix for 3 of the same branch is tri. The branches each have 1 carbon, so still working in meth here. Methyl, trimethyl, and then again we have 6 carbons total. Hex is my prefix for 6. 2,3,4 trimethylhexane. 2,3,4 trimethylhexane. All right, number 6. Hit pause, take a look, draw it, and then come back. All right, with this one, my parent chain, I've got 3 carbons sticking off here, I've got 3 carbons sticking off here, I've got 3 carbons sticking off here. This is clearly my central carbon. It doesn't matter what direction you use, you're going to have the same parent chain, 7 carbons long. Okay, I'm going to use this one as my parent, this one as my branch. First off, numbering direction. Again, because this is the center carbon, it doesn't matter which direction you number it. It's attached to carbon number 4, no matter what you do. Okay, so that's my location for, whoops, not a comma, 4. And this one, we have 3 carbons in the same branch. So that is not tri. We don't do tri for that. 3 carbons in the same branch is prop. Prop meaning 3 carbons, YL meaning it's a branch. So 4 propyl, and then it's attached to a 7 carbon molecule, so we get heptane. 7 carbons is hept. So 4-propyl heptane. Okay, we're halfway done. Here's our next one. Pause, draw it, and come back. Okay, this one's much more complicated here. So if we're looking at parent chain first, that's always first. We got a couple options if you just try to find the longest chain. 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. Now, you want to focus on those branches though, because if I go this way, that means my branch has a branch, and let's just not go there. Let's keep it simple. Okay, my parent chain is this long, straight 5-carbon molecule, and it has 3 branches coming off of it. I won't ever give you one where a branch has a branch. We're going to stick to this. So make sure that you find that parent chain that all of the branches are attached to. So now we have 3 branches. We have a methyl because it only has 1 carbon. We have another methyl over here, so we're going to have to combine those in the name. And we have an ethyl because it has 2 carbons. Okay, so number 7 up here are locations. Well, which one comes first in the name, a methyl or an ethyl? Well, the answer is ethyl. Even though we have 2 of these, and that's going to become dimethyl, the methyl part is what we focus on for the alphabetical order. So ethyl is going to come first. It is at carbon number 3, no matter which way you work it. So carbon number 3 is our ethyl. 3-ethyl is the first part of this name. Then we're going to number our other 2 branches. Well, it doesn't matter which way you numbered it. Carbon 2 and carbon 4 have a methyl. So 2, 4. Again, combining those together, we're going to use the prefix on the prefix. We get di for 2 of them, methyl for single carbon branches, 2,4-dimethyl, and then they're attached to, again, my parent chain has 5 carbons, so 2,4-dimethyl pentane will finish us off. 3-ethyl, that's this guy, 2,4-dimethyl, that's these, pentane. All right, number 8. I don't know why, but sometimes people get stumped with this one. So pause, focus on the carbons, and then come back. Okay, this one only has 2 carbons. There's no branches. There's no complexity. 2 carbons with a single bond. Remember, that single bond right there is between the carbons. These hydrogens are with this carbon. They're actually existing here, here, and here. Okay, this carbon is bonded to this carbon. 2 carbons, single bond. Eth means 2 carbons. ANE means single bonds. Just ethane. All right, number 9. Pause, name, come back. Okay, with this one, we've got 4 carbons in a row. 1, 2, 3, 4. Even if you go this way and bend it, you've got 4 carbons in a row. So that's the longest chain. When you number it, you have to give your branch the lowest possible number. So 1, 2 would be lower than 1, 2, 3. So we're going to number this way. 1, 2. So my location of my branch is 2. My branch name, well, it only has 1 carbon. So that's methyl. Meth for 1 carbon, YL for branch. And then it's attached to a 4-carbon molecule, so we get butane. 2-methylbutane. We're almost done. We're only going to 12, and the last 2 are drawings. So here's number 10. Pause, name, and come back. Okay, I threw this one in here again. I need you to just be able to recognize all of these structures so you can see them drawn anyway on the quiz when we get there. So here, every point is a carbon. So 1, 2, 3, 4, 5, 6, 7. There aren't any branches. 7 carbons. Each line is a single line, which means that's a single bond. We'll get into double bonds later. But 7 carbons, single bonds. Hept means 7 carbons. ANE, single bonds. This is the skeleton structure for heptane. Okay, actually, I'm going to flip this over because we're going to be drawing now. So your paper, you can't do that too. You can probably have to just draw on top of lines, but here we go. 4,5-diethyl, 2-methyl, 6-propyl, nonane. Aren't you glad you get to draw this one instead of having to name it? Okay, pause and try to draw it. Remember, when you draw, you start with your parent chain. and then you start adding stuff to it. So pause, draw, and come back. Okay, drawing that parent chain. Okay, I'm going to do a carbon skeleton because I've found in the past most of my students prefer that type of drawing. So for number 11 here, non-ane. Well, non-ane, ANE is single bonds, non is 9 carbons. So I'm just going to shoot out 9 carbons here, all in a row. You are allowed to bend that if your paper doesn't give you the space to do them in a row. Just bend it around, okay? But 9 carbons all in a row. Okay. All right. Next, I'm going to start adding stuff. It doesn't matter what order you add them, but just pick a direction for numbering. 4 and 5 both have an ethyl. So 1, 2, 3, 4, and 5 have an ethyl, because di means we have 2 ethyls in this whole molecule. They are attached to 4 and 5. Ethyl means it has 2 carbons and it's a branch. Okay. You're not going to do this. This is not an ethyl. That's 2 methyls. Okay? Don't do that. An ethyl is 2 carbons together as a branch. Okay? So do that again over here. That's our 4,5 diethyl. 2-methyl. 2-methyl. Keep in mind, you could have chosen to draw these above or alternating above and below. It doesn't matter. As long as it's attached to the second carbon and it's a single carbon branch, that's your 2-methyl. Just make sure you're continuing to use the same direction. If this is my carbon number 1, it's my number 1 for everything. So finally, 6-propyl. 1, 2, 3, 4, 5, 6 is my location. Propyl is 3 carbons because prop means 3. And again, all 3 are in a row because it's a single branch, propyl. So 4,5 diethyl, 2-methyl, 6-propyl, non-ane. Okay. Real quickly, if you do like the skeleton structure, because I like to encourage kids to like that because it's my favorite, I'm going to show you that skeleton structure. So put your pencil down. That's number 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. You just, every time you move, that's another carbon. Okay. Coming off of 4 and 5, 1, 2, 3, 4, I have an ethyl. Well, ethyl is 1, 2 carbons. Coming off of number 5, I have an ethyl. 1, 2 carbons. Doesn't matter which direction you go with that angle. Coming off of carbon number 2, I have a methyl. And coming off of number 6, I have a propyl. So 1, 2, 3, 4, 5, 6. Propyl is 1, 2, 3. There you go. Okay, last but not least, pause the video and try and draw 2,3,5,7 tetramethyl octane. All right, this one, my parent chain is octane. So the very end of that name is your parent chain, okay? So octane, 8 carbons. Okay? I think even my 3-year-old could tell you that oct means 8 because of the stop signs. Okay, tetramethyl octane. So methyl, meth means 1 carbon, YL is a branch. So methyl is a single carbon branch. Tetra means there are 4 of this thing. There are 4 single carbon branches attached to octane. And here's where they're located. 2, 3, 5, and 7. 2, 3, 5, and 7 all have a methyl branch attached to them. And a methyl is only 1 carbon. So that's it. Done. You could put them up, down, up and down. Just make sure that there's only 1 carbon attached to each of those, any direction. Skeleton structure, octane, 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 5, 7. And there you go. Hopefully you guys did well. Now you have the ability to finish all of the problems for 22.1.